Down the properties. So let's just write these down real quick. And I'm going to write them a little different than your book does. So here's what we need to know. If I have a limit of f of x as x approaches c, and that equals L, and then I take the limit of g of x, which is a different function, as x approaches c, and that equals m. Then the limit of f plus x, f of x plus g of x, is equal to L plus m. And you might think, well, Mr. Adams, that's kind of dumb. No, it's easier, because sometimes we could take these really complicated functions and make them a sum of two functions. Then we take the limits of each individual functions and add them up. Another property is that if I were to do, when we're subtracting, it's really kind of the same as adding. So if I did the same thing but I was subtracting the functions, then it would just be L minus m. Now if I were to multiply these, in other words, if I were to say the limit of the function f, right, times the limit of g, it's equal to L times m. Now if I were to divide them, that's a different rule. To divide them, if I say the limit of, and we'll use this one a lot too, f of x divided by g of x as x approaches 0, that's just going to be L divided by m, but what's the exception? M cannot equal 0. Now if I say the limit as x approaches c of some constant k times f of x, that could be just k times the limit, and we'll show you how to do that too. So k is just a constant.